For our last section in Chapter 5, we are going to look at inequalities in triangles. The corollary to the triangle exterior angle theorem says the measure of an exterior angle of a triangle is greater than the measure of each of its remote interior angles. So we can see by our diagram that angle 1 is our exterior angle. So this means that angle 1 will be greater than angle 3, and angle 1 will be greater than angle 2, which back in Chapter 3 we learned that we could find the measure of angle 1 by adding angles 2 and 3 together, so then it's kind of obvious that angle 1 has to be bigger than both of those angles. The largest angle theorem says if two sides of a triangle are not congruent, then the larger angle lies opposite the longer side. Okay, number 1 says a landscape architect is designing a triangular deck. She wants to place benches in the two larger corners. Which corners have the larger angles? So we said that the largest angle will be opposite the longest side. So if my longest side is AC, then opposite that would be angle B. So angle B is one of my larger angles. And then I see my next longest side is AB, and that is opposite angle C. So angle B and angle C are my two larger angles. Number 2, list the angles in the triangle from smallest to largest. So my shortest side is side BC, which is opposite angle A. So angle A is my smallest angle. Then angle C. Oops. And finally angle B. Okay, and number 3 it says triangle RGY, or we are given triangle RGY. RG is 14, GY is 12, and RY is 20. List the angles from smallest to largest. Sometimes with these problems it helps to draw a diagram, and it doesn't have to be drawn to scale, but we have triangle RGY. Here we go. Where RG is 14, GY is 12, and RY is 20. So remember, the smallest angle will be opposite the shortest side. So angle R is my smallest angle because it is opposite side GY. Then angle Y is my next smallest angle. It is opposite side RG. And finally angle G is my largest angle because it is opposite side RY. Okay, the largest side theorem says if two angles of a triangle are not congruent, then the longer side lies opposite the larger angle. And in number 4, it says in triangle FGH, G is a right angle F equals 70 degrees, and angle H equals 20 degrees. What is the longest side? So again, it might help to draw a diagram here. We're told that G is a right angle, so I'm going to draw a right triangle. I know that G is at my right angle, so then I'll put this as F and H. So F is 70 degrees, H is 20 degrees. Which is the longest side? Well, that's going to be opposite my largest angle, which is G. Opposite that angle is side HF. Number 5 says list the sides of triangle PQR in order from shortest to longest. Well, if you take 180 and subtract the two angles you know, you find that angle P is also 75 degrees. Well, our shortest angle will be opposite our shortest side will be opposite our smallest angle, so that's going to be side PR. And then our next two sides, even though they don't look it, are the same length because their angles are the same measure. So I'm going to next put QR and then PQ. The triangle inequality theorem says the sum of the lengths of any two sides of a triangle is greater than the length of the third side. And we see that in our triangle below, that side AB plus side BC is greater than side AC, that BC plus AC is greater than AB, and that AB plus AC is greater than BC. We're going to use this theorem in our next examples to find what are possible lengths of some of our triangles. Okay, in number 6 it says if a triangle has two sides of length 3 and 10, what are possible lengths of the third side? Well, I'm going to use X to represent my third side. Okay, and our theorem had said that the sum of two sides of a triangle needs to be greater than the third side. So I was given two sides of 3 and 10. So the sum of those two sides has to be greater than my third side. So if I add these two together, I get that 13 is greater than X, or that my third side has to be smaller than 13. Well, then I'm going to choose the smaller of the two sides I was given, which is 3. And then if I add my third side to it, that also has to be greater than 10. If you subtract 3, you get that your third side has to be greater than 7. So that means that your third side has to be between 7 and 13. And number 7, can a triangle have side lengths of? Well, in A we have 3, 8, and 6. Okay, so again, the sum of two sides has to be greater than the third. So is 3 plus 8 greater than 6? Yes. Okay. We'll stick with the 3. Is 3 plus 6 greater than 8? Yes. And is 8 plus 6 greater than 3? Yes. So a triangle could have side lengths of 3, 8, and 6. Okay, let's try B. 3, 8, and 4. So is 3 plus 8 greater than 4? Yes. Is 3 plus 4 greater than 8? Ooh, no. Okay, so B is a no. Cannot have a triangle with those three side lengths. And finally C, is 3 plus 3 greater than 3? Yes. And actually, if all three sides are the same, that is an equilateral triangle. Okay, let's look at our last two examples for this section. We're going to find out which side is the longest in both of our examples. In number 8, we have triangle PQR, and we have angles identified. However, we do not know how many degrees each of our angles are. So we first need to write an equation to find our missing angles. Well, remember that the interior angles of a triangle add up to 180 degrees. So I can add up my angles, so 3x plus 21 plus 8x minus 5 plus 7x plus 2 equals 180. I combine like terms and get 18x plus 18 equals 180. And then solve for x. Subtract 18 and divide by 18. Get x equals 9. And then you can use a calculator to plug in and find your missing angles. I did that and got angle Q is 48 degrees, angle R is 67 degrees, and angle P is 65 degrees. So my largest angle is angle R at 67 degrees, which makes my longest side PQ. It is the side opposite my largest angle. Alright, and in number 9, we have two triangles that have formed a quadrilateral. In triangle ABC, our last missing angle at C is 51 degrees. And in triangle ADC, our angle is 129. Okay, so my largest angle is 129 degrees. But to form this angle, if I follow my segments for angle D, it takes me to A and C. Now I can only pick one side as the longest side, so that doesn't help me. But if I go to my next largest angle, which is angle BAC, and follow my line segments that form this angle, I find that side CB is my longest side. All right, so this concludes our last section in Chapter 5, Inequalities in Triangles.